Good morning, friends. In the last session, we have discussed about statically determinate beams and how to find out the support reaction for statically determinate beams. In this session, we are going to study further numericals. We are solving more problems and we are trying to understand that how to find out the unknown parameters, that is the support reaction. We learned in the previous session about the types of supports, types of beams, specifically the statically determinate beam, types of loads which are acting on beam, and we had also solved certain numericals based on this particular beam. Now in this session we have to solve certain more typical numerical with the variety types of the loads, with the combination of the loads on the beam. Let us be revised. What is beam? That is a structural member that carries a load from that slab that is applied transverse to its length and transverse to the column. What are the reaction forces? The forces which are generated at the support, the resisting forces, are known as the reaction forces, and our intention is to find out these reaction forces in this particular chapter. We had studied already the principles of equilibrium. That is, first, that is sigma V is equal to 0. What is sigma? Sigma is the representation of symbol of summation. V, that is the vertical forces. So summation of all the vertical forces or the component of vertical forces acting on a body must be equal to 0. That is our first principle of equilibrium. Second, sigma H is equal to 0. Sum of all the horizontal component of forces acting on a body must be equal to 0. And the third, sigma M at any certain point, let over here P, is equal to 0. That is, the sum of all the moments acting on a body must be equal to 0. Yes, I think you should know what is the meaning of moment, because this fundamental must be clear in your mind before we are going further proceed. What is moment? It is nothing but the product of force and the perpendicular distance from the line of action of force to the point of application. Next, several types of loads can act on a beam. Categorized. The first one, that is the point load, concentrated load, the load which is acting at a certain point, that is known as the point load. Distributed loads, the load which are distributed on the area, on a length, specifically on a beam. The two categories are there: uniformly distributed load and uniformly varying load. The load which are uniformly distributed over the length of beam, and another load, that is loads which are uniformly varying along the length of beam. And the couples, that is the moment, concentrated moment acting at a point. We already studied all these things in the previous session. This is the example of the point load, how the point load is acting. What is the characteristics of the point load? First, having a magnitude as well as unit and acting at a certain point, like By, that is reaction acting at point B, that is of 15 kilonewton. Examples of the UDL, short form of uniformly distributed load, the load which are uniformly distributed along the length of the beam. Unit is kilonewton per meter. Per length of meter, the load is varying along the length but equally distributed. This is uniformly varying load. Load which is uniformly varying along the length of the beam. We have also studied in the previous session types of the support. The knowledge of all these things is compulsorily required, because then we can proceed further for the solution of the more numericals. The first support, that is a roller support, which offers single reaction, that is the normal to the support. Pin connection, another name is the hinge connection, offers the two reaction, that is first horizontal and second is vertical. While the third support, that is the fixed support, offers the three reactions, that is the horizontal reaction, vertical reaction and a moment at that particular joint. These three reactions will be offered. We also studied statically determinate beams and the types. The first is the simply supported beam. Yes, please define what is simply supported beam. Beam having the one support roller, another support hinge is known as simply supported beam. That in this simply supported beam, because of the hinge support, the two reactions are unknown. Visualize over here. Here at this joint, two unknowns are there. Here at this joint, one unknown is over here. So total in this particular beam, 1, 2 and 3 unknowns are there, and hence these three unknowns we can found out with the help of the three equilibrium conditions, that is sigma h, sigma v and sigma m is equal to 0. The another beam is the cantilever beam. This cantilever beam is defined as a beam whose one end is fixed, another end is free. Remember, the another end is free, there is no support over here, only single support, that is the fixed support over here. Because of this fixity, three reactions will be offered, that is FH, FV and M, and these three unknowns we can found out with the help of three equilibrium conditions. The another beam, that is overhanging beam, the beam whose one end or both the hand projected beyond the support. Please carefully visualize, this particular portion is projected beyond this support, hence this beam is known as overhanging beam. Once again, in this beam, three reactions are unknown. See the previous one, these three reactions are unknown and we can found out these three reactions with the help of equilibrium conditions. Yes, please recall once again, can I say that the beam where I will provide two roller should be considered as a statically determinate beam? Definitely no, because it is an unstable beam. Why it is an unstable beam? Because any component of horizontal force, any component of the force, specifically the horizontal component of force, leads instability of a beam. Hence, a beam with the two roller considered as unstable beam. Yes, see the figure, simply supported beam, cantilever beam and overhanging beam. We have already studied these things in the previous session. Sign convention used throughout in the previous session as well as in this session. Repeat the word, this is my assumed sign convention. Person to person, this sign convention may go change depending upon his or her conveniency. Like for my case, I have used horizontal force, right hand side arrow is considered as a positive while the opposite side is considered as a negative. Similarly, for vertical force, all upward forces are treated as positive while downward force treated as negative, and for moment, all the clockwise moments are treated as a positive while anti-clockwise moment treated as negative. You can take vice versa of this also. Now we will solve certain numericals today. Start with the first numerical. Yes, would like to ask the question, which is this kind of beam? Yes, this beam is known as overhanging beam. overhanging beam, see carefully, hinge support, roller support, and this span is projected beyond the support. Hence this beam is known as the overhanging beam with UDL throughout. UDL, uniformly distributed load of 10 kN throughout acting on a beam. That is, our aim is to find out the support reaction at A as well as at B. How to find out? Let us, we are drawing the free body diagram. At A joint, the two reactions are possible, RAH and RAV, while at B, single reaction is possible, that is RB. Now, to find out these three things, let us use the first equilibrium condition. Sigma H is equal to 0, and see the previous figure. I have to draw a sketch for the explanation point of view. A joint, this is B joint, and throughout UDL is acting. This length is 4 meter, this length is 2 meter. This is my RAH. Now, in this throughout the system, only RAH which is acting as the horizontal force. None of the force which is acting horizontal in this particular system. So, simplified, this value is treated as 0 because sigma H is 0, RAH comes to be 0. Next step, sigma V is equal to 0. Yes, remember what is sigma V? Summation of all the vertical component of the forces acting on a body are 0. Now in our case, the body is beam. In this beam, how many vertical forces are acting? Yes, this is my first force, RAV, comes over here please, in this page. RAV is a vertical force, RB is also vertical force, and this third one, UDL, is also vertical force. So 1, 2 and 3 are the three vertical forces acting on this particular system. Now see the sign convention. What is sign convention? We are assuming upward treated as positive. So if we take sigma V is equal to 0, then RAV upward treated as positive. Next, this 10 kilonewton per meter acting throughout the length of beam of 6 meter. So the total load which is acting 10 into 6, 4 plus 2 is the 6 meter. The unit of 10 is kilonewton per meter into meter, that is the 6 meter. So this meters goes out, we want kilonewton. This is acting downward. Downward means treated as negative. Upward RB is acting, plus RB is equal to 0, and we will achieve a one single equation, RAV plus RB is equal to 60. Please see this over here. That is, to obtain an equation, RAV plus RB comes to be 60 kilonewton. Now let us use the third equilibrium condition, that is sigma M is equal to 0. Now when we are using the condition sigma M is equal to 0, precisely at certain point we have to take, let us, right now I will repeat word let us. Let us means assuming, you may take any of the point. So right now for the simplifying point of view, let us we take point A for our reference. Sigma MA is equal to 0. If we see the figure, previous figure, we are taking the moment of all the forces acting at this point which is treated as 0. We are taking the moment of all the forces at this point. Now let us comes to be over here and understood the point. we are taking sigma ma is equal to 0. Now RAH into 0, 0, RAV into 0, 0, because we are taking a moment over here. Now the remaining forces, this 10 which is acting downward, UDL. So now 10 into 6 is the total load which is acting at the CG. What is the location of CG? Length is of 6 meter. So CG which is at over here. This is 10 into 6. So what I did, I convert my UDL in terms of equivalent point load which is acting at the CG of load, and this distance is of 6 by 2. This creates a moment, clockwise moment, so treated as positive as per our sign convention. Another force, that is RB. This creates anti-clockwise moment, treated as negative. RB into perpendicular distance from A, that is of 4, is equal to 0. If we simplify, RB comes to be, now please see, 10 into 6 is what? Force. Multiply by distance, it is to be remaining over here, that is 6 by 2, this factor. So finally we achieve 10 into 6 into 3, that is 90, multiply by 4, we obtain the answer. See the figure. So we obtain the RB comes to be 45 kilonewton. Now RB comes to be positive. RB comes to be over here positive value. Positive value means our assumed direction of RB is right. Now we will put this value of RB in the first equation so that we will find out